Any ideas? It's a special property. This is reflexive. Reflexive property. Remember, symmetric property is when you guys have an equation of two different things, like x equals 5. Those are two different things, and you swap the order. Reflexive is when you say something is completely equal to its exact same self. All right. We use this. It's kind of a weird way that we use the reflexive property in these proofs, but we need to make sure that that's still something we use. All right, what about this one? Ray TW bisects angle VTS. Based on just that, what's another conclusion I can make? Okay, so you can say angle 1 is congruent to angle 2. Right? How do I know that? Definition of bisect. When you guys are doing proofs, not only do you state properties and postulates and theorems, you can also state definitions. So you can say, well, that's the definition of bisect. I know that this is true because I know what bisect means. Okay, we use that a lot too. What about this one? Segment AC bisects segment BD. So something that I could write based off of that. I know that one of the segments bisects the other.
BE is congruent to DE.
BE is congruent to, oops, did you say DE? Okay, like that. If you were to see this and I asked you to put a marking in the picture like we were doing in Unit 1, and you saw directions like bisect, I told you guys to put the marking in the picture so you knew how to solve. If you guys saw that BD was being bisected, you would do this, right? Because bisecting is to cut in half. So any markings that you put in the picture, a proof is basically just writing it down in words. If you would have written that in the picture to solve, you just write it here in the proof. And again, we know that because of the definition of bisect. All right, what about this one? E is the midpoint of AC. You guys saw that in a question and I wanted you to solve or something. I said E is the midpoint of AC. What would you add to this picture? I would say that this is equal to this, right? Because what does midpoint mean? It's right in the middle, so it cuts the segment in half. So then what would I write? How would I represent that in words? AE is congruent to BC or CE, doesn't really matter. Right, and I know that because of the definition of midpoint. You see how I can make these conclusions based on a previous step? That's a really crucial understanding for working through proofs. And then, of course, we could use the angle addition postulate and the segment addition postulate. If I see this picture right here and I say ST equals something, what would ST be equal to in this picture? I don't have any numbers, you just need to work with the diagram. What would ST be equal to? No ideas? A couple different ways that you could write it. No, SVT is an angle. That's another way of stating ST. Say again? ST equals ST. I don't want the reflexive. I'm trying to use the segment addition postulate.
SH plus H1 plus O2.
Good. SH plus HO plus OT. You take all the little pieces and add them together. Isn't that equal to ST? That's the segment addition postulate. Told you guys when we learned that, it comes back in proofs. And that's how you would use it. You would take a full length of a segment and you chop it up into pieces, add them together, get the whole thing. We use that a lot too. Same thing for angles. For this next one, I could say that angle SVT is this angle, SVH plus HBO plus OBT. The full angle is equal to all the small ones added together. That's by the angle addition postulate. And then for this one, if I said the angle BEA was equal to DEC, why would I know that? because they're vertical angles. We use vertical angles a lot too. So if you want to say that two vertical angles are congruent, you would just say that they're congruent and say the reason would be vertical angles are congruent. It's pretty straightforward. So those are the most common things that we use for writing proofs. So now we're going to actually jump into our notes here and see how we can use those to help us. So there are two different types of proofs I'm expecting you guys to know how to do. The fill in the blank type proofs, which is where I have some of it already set up for you. You have to either give me the reason or give me the statement that goes with the reason provided to complete the proof. Now in red, I have up here a really good step-by-step strategy you guys should follow for tackling proofs. You want to read the given, right? So they're always going to give you some information about your picture. You want to read the given, add marks to your diagram, right? Always work with what's up here first before you start working on the proof. Get as much out of the diagram as you can. So you're going to read the given, add the given marks to the diagram or any other marks that you might notice need to be added. Then you're going to strategize. Before you start writing a proof, you just want to think about it in your head. How could I go from step A to my final destination or step B? What steps would I go in between to get from here to here? Strategize. Think about it in your brain a little bit. Then after you have some sort of plan, then you guys are going to work through the proof slowly, right? Take your time and don't skip any steps. And you're going to keep the proof equation as your end goal. You need to tailor the proof so that it looks like this in the end, right? What do you notice about the given here? I start with AB equals CD and CD equals 7. What do you notice about the proof? Does the proof mention AB or CD at all? No, so somehow I have to go from A, B, C, D, and then merge that into A, C, and B, C. So when you compare the given and the proof, you can see what changes need to happen, and you need to make sure that happens in the body of your proof. So always keep the proof in mind. I need to somehow get the AC and the BC in there to help me get to that equation. All right, so in this proof, I know that AB is equal to CD, so I put these little markings. Right, remember that means equal, so I put them in. And then I know that CD is equal to 7, so I'm going to label that with a 7. Right? Now stop looking at the proof. Let's just strategize. How can I prove that AC is equal to 7 plus BC?
Because AB is congruent to CD, so AB is 7.
Okay, so that's something we know. If that's 7 and they're congruent, that means this is 7. All right, so that's something we're going to need to include. What else? How can I conclude that AC is equal to 7 plus BC? I now know that this is 7. Keep going. No ideas on how I could get AC being equal to 7 plus BC?
That's AB and BC equal AC.
Okay, so if you take AB and BC and put them together, you get AC. What's that called? You take two part plus part equals whole. Segment addition postulate, just like I told you guys when we learned it. I'm using it in proofs, and we need to state it by name. When you take part plus part equals whole, chop it up like that, that's the segment addition postulate. So that's basically our proof. You guys just thought through it. Since we know this is 7, we're going to say that this is 7, right? And because we know that AC should be equal to both of these together, we're going to add them together to get them to equal AC. That's basically our strategy. Now we just need to write it out in words, okay? So your very first step in a proof is always your given. So whatever you have provided for you, you always want to write that down first. That's your foundation. So they're going to provide this step, and then it's given. First line is always really easy. Now, what was the next thing you guys figured out since you saw this picture? What was the next thing that you concluded? You concluded that AB was equal to 7 as well, right? So we're going to write that down. That's going to be our next line. AB is equal to 7. And the reason we know that is the substitution property, officially. Since this is all we know right now, for a proof, you kind of have to pretend that the person reading the proof that you're writing this for doesn't really understand geometry. So instead of saying, oh, it's because they're congruent, right? Instead of that, you're going to say, well, since I know that CD was 7 and I saw a CD right here, I plugged it in. I substituted. So we're kind of reverting back to Algebra 1 instead of geometry to prove this. So instead of just saying, oh, it's because they're congruent, you say, I had an equation, I saw what CD was equal to, I plugged it in, now I have AB equals 7. You gotta break it down. Everybody see where we are right now? Okay. Now I went here, I said that AB plus BC is equal to AC. What gives me that? Why would I know that? That's the segment addition postulate. AB plus BC is equal to AC. Remember, we needed this setup because that's what our proof looks like. Now that I have the AC in the formula like I needed for the proof, AC showed up and now BC showed up. So now we're on the right track. It's looking closer and closer to what this looks like. All right, what can I do next to make it look even closer to this? Do you guys recognize anything between step 2 and step 3 that I could kind of merge together? Yeah, don't I know what AB is? You see AB here? Maybe I don't want to write AB itself anymore. What could I put instead of AB? 7. So I can adjust this equation using the previous steps. I can get it to look even closer to the proof statement by swapping out AB for 7, but the official name for that is substitution property. And then this isn't exactly what they wanted it to look like. They wanted it to be reversed the other way, so I just rewrote it. Do you guys remember what that property is when you switch the equation, which side it is? Remember what that property is called? That's a symmetric property. When you rewrite an equation so that the left side was on the right side, just switch symmetric property. Alright, so that's our proof. Alright, that's our first example. Let's take a look at the next one. Same picture, but different thing that they want us to prove. So this time they're telling us that AB is equal to CD. So I put my little markings in here. They didn't give me any numbers. What they want us to prove is that AC is equal to BD. So they want this section right here, A to, oops. They want AC to be equal to BD. Right? What do you notice about those segments that they named, AC and BD? They're overlapping. So we're going to have to take that into account when we strategize with the proof. So, do you guys have any strategies that we might be able to use? Can you think of some ways that we could go with this proof before we start writing stuff down? My suggestion, and it could just be me, because some people can do this without needing to really visualize it. Some people do prefer I don't think I did that right. Hold on. Some people like to draw the segments separate. Remember how I mentioned they're overlapping? Some people like to draw them separate, so it makes a little bit more sense. So this would be B, C, D, and this would be A, B, C, like this. You can draw them separate. Like that. That sometimes helps people kind of spark an idea on what they're supposed to be doing, particularly when they're overlapping. I'm trying to prove that BD is equal to AC. Anybody have any ideas, or are we going to start working through the proof? See what we arrive at. No ideas? Well, how can we get off to a good start? What would that first blank in step 1 be? Get. That's always easiest, right? Oops, I need my pen. Alright, so it is given, alright? Now the strategy here, you guys may not be able to see it, but the strategy that we're going to go through is, since I need to say that BD is equal to AC, the full length is equal to this full length. You see how it's chopped up into pieces? I first need to say that all the pieces are equal. Because you can't say that the full lengths are equal unless you know all the little pieces are equal. What do you guys notice about the segments I haven't marked? They're the same. Do you see how it's BC and BC? Okay. So since I know that they're both the same segment, oh man. Since I know they're the same segment, I know that they're congruent to each other. So what you guys can do is go ahead and put a double mark on BC, both of those segments. I can't write it anymore. But if you go ahead and put a double hash mark on BC and BC, now we have two segments that are equal to each other, and another two segments that are equal to each other, and I can add them to get the full length. That's my strategy. Okay? So So the next thing I'm going to have to say is that BC is equal to itself. If this thing will let me. It doesn't seem like it will. 1 second. Right. Your next line should say BD is equal to BD. It won't let me scroll, but it'll let me move stuff. That's interesting. Hold on. This is too early in the morning for you to mess up on me, technology. Right, BC is equal to BC. You saw that in the picture, they're congruent to each other, and that is by the reflexive property. You guys do need to know that, because remember, some proofs will be completely fill in the blank. So you need to know that when you say that something's equal to itself, it's a reflexive property. All right, then I'm going to say that AB plus BC is equal to BC plus CD. What property lets me go from line 2 and line 1 to create line 3? It's a little more abstract. So getting step 1 and step 2 compared to step 3, what did I do? Say again? Plug your what? Well, plug, you mean like substitute?
Yeah.
You don't want to say substitute because that means you swap something out for something else. You're going to do that, yeah.
Could it be like addition?
Yeah, it's actually the addition property, right? The addition property is when you add the same thing to both sides of an equation. Didn't I do that? I just took the equation from step 1 and I added BC to both sides. Just like I drew that picture, which you can't see anymore because I can't scroll. But in that picture that I drew before, I separated them and I had BC separate for both of them. That's what this equation represents. Both of those little segments. I have AB plus BC is equal to BC plus CD. And the reason why I can write the equation accurately is because of the addition property. I said that BC was equal to itself, so I can add it to both sides. All right, so now I know that the two segments are equal to each other, but I was trying to prove that AC is equal to BD. Do you see AC, BD anywhere in here? Okay, so it's time to bring those in. I need my last statement to be AC is equal to BD, and I currently don't have those. So I need to start bringing them in. How could I introduce AC? What do I know about AC?
AC plus CD equals A. Oh no.
I need to define AC. If I'm bringing it in, I need to define it. Yes. Okay. I'm going to define AC by using the segment addition postulate. When you're bringing in a new idea to your proof, you need to define it in the best way that you can. The way that we define a segment is by saying what it's equal to. So AB plus BC is equal to AC, segment addition postulate. I also need BD in my proof statement, so I'm going to introduce BD the same way I did for AC. BC plus CD, in the segment that I drew up there, is equal to BD. And how do I know that? Segment addition postulate again. So when you introduce an idea, you need to define it. Now what do you notice about step 3 compared to step 4 and step 5? You have everything you need. How can you use steps 3, 4, and 5 together? Yeah.
And that would be AC equals BD.
How?
Because AB plus BC equals BC plus CD. So if AB plus BC equals AC, then BC plus CD equals BD.
That's a lot of words, right? So using what property, essentially? You notice that, do you guys see how I see, or I have AB plus BC twice? I have it in this equation, and then I have it here. Remember I said when you see the same thing twice, what could you do? Can I substitute this piece right here for AC? So instead of writing AB plus BC, I could just write AC, so now it's equal to that, so I substitute that in. Do you guys see BC plus CD anywhere else? Right here? What's BC plus CD equal to? BD, so I can then swap it out right there, and that's exactly what my proof statement looks like. Exactly what my proof statement looked like. So step 3 and step 6 are the same thing. They're saying the exact same thing. I just needed it to look like my proof statement. I needed it to be in terms of AC instead of the pieces. I needed the whole instead of the purple part. So that's all that I did in step 4 and step 5, was define what the full segment was instead of having the little pieces chopped up. And again, that's your substitution property. That's a substitution property. I just took the longer pieces of the equation and substituted in what I knew what they were equal to. Again, substitution is the most popular step in a proof. Taking something, kind of narrowing it down to one specific item and then plugging it in to simplify the equation. Alright, so that's the second part. I'm going to give you guys a quick second. I want you guys to talk to the person next to you if you have any questions, if you're confused or want to talk about it. Go ahead and talk with the person next to you for a second. Alright, go ahead and close your conversations, please. Any questions to voice about the first two? Okay, let's take a look at this one right here. This is going to be our last fill in the blank proof, and then the ones on following pages are from scratch. Alright, so this one says, given T is the midpoint of AM. When you just see that, how can you put that into the picture? You know these are equal, right? We know in our head why. It's the definition of midpoint, right? So hold that in the back of your thought. How are we going to be using that at some point? Since we saw midpoint and that reminded us that they're equal, we put the hash marks in, we're going to be writing it down somewhere in the proof. But what I'm trying to prove is that AT is equal to half of AM. So somehow I have to take the fact that AT is equal to TM and then get this equation to show up. So I'm going to have to do some equation manipulation to get it to look exactly like this. We can't go straight from AT is equal to TM, so duh, it's half. Right, we can't make that jump. We need to be using algebraic steps and working through the algebra aspect of this to get to that equation. Can't take too big of a jump in proofs. So what should our very first statement and reason be? Exactly what they gave you for the given. T is the midpoint of AM, and that was provided for us. That's how you always start a proof. The immediate following step is going to be whatever you concluded from the given. So when you saw the given, what was the first thing that you concluded? AT is equal to TM. That's always the next step. Whatever you can conclude from the given. Whether that's one thing or multiple things, that's the first step that you write. So note AT is equal to TM. Alright, I don't know anything besides that from the given, so now what I need to do is take that step and manipulate it a little bit. Now I need to start working to get towards my prove statement. So what's something that I could write now? It's provided for you. I say that AT plus TM is equal to AM. How do I know that? That's your segment addition postulate. Now why did I know I was going to do that next? Look back at the prove statement. What's in the prove statement that's not in the statement for number 2? AM. So I had to introduce AM. Remember, when you guys look back at the proof statement, you know what should be within your proof to get to that equation. I hadn't introduced AM yet, so now I'm going to do that. So I know AM is equal to part plus part equals whole. Second division postulate. Now what? Look at step 2 and step 3 together. What could I do? I can say that AT plus AT is equal to AM. What did I do? I substituted. I know that AT is equal to TM, so instead of writing TM, I just wrote another AT. Here's a question. If I knew that AT and TM were the same, why didn't I say TM plus TM? equals TM. Because there's no TM in the proof. That's why it's important to keep checking the proof statement to know what you're supposed to be left with by the time you get to the end. All right, now what? I have two ATs, so I'm just going to algebraically write it as 2 times AT equals AM. Remember, we're trying to get it to be 1/2, so if I start with 2, that'll make it easier, right? So then what's my last step? Last step to go from 2 AT equals AM to AT equals 1/2 of AM. Division property to get your 1. All right. Anybody have any questions on that one? Again, remember, when you guys are working through this, you start with the given until you can't do anything more with it. Make sure you introduce all of your information for your proof and you manipulate the equation to get there. Okay? All right, deep breaths. Here come the ones that have to be completely your own. All right, these are the ones that are going to be monsters to grade, so Lord help me when we get to the test. For the proof, there are lots of different ways, well, not lots, there are different roads you guys can take to get to the final answer. There is a minimum number of steps you can take, but the maximum is really up to you. So it's hard for me to teach you guys how to create proofs by scratch because it's my proof, the way that I think it should go. But again, when you guys are creating proofs yourself, as long as you have the main ideas there, the route you take is really up to you. All right, so we're just going to work on this together according to how I might go through it, and then I'll give you guys an opportunity to do your own kind of setup. All right, so what am I provided in this picture? I know that angle 1 and angle 2 are complementary. Then I know angle 3 and angle 4 are complementary. We don't really have any symbols or anything, markings to put the picture for complementary, so I'm not going to be able to do that. But if you look at what I added in the picture, what did I go ahead and add in the picture before I started? Vertical angles, all right? Before you start the proof, add everything that you can into the picture. You might need to go back and reference the picture and add more information as you're going through the proof. We can't get to this based on just this. We're going to have to go back to our picture and use that to help us create more ideas to use for the proof. So I went ahead and put that into the picture that I have vertical angles, so I'll probably use that later. So what's my first step in the proof? It's always what you were provided. I'm going to go ahead and write that down. You guys can abbreviate complementary to COMPL, like COMPL. I'm fine with that. As long as I can understand what you are expressing. You're going to write the given exactly as they provided it for you. The fact that you have 2 complementary angles. Now you guys are going to tell me what you can conclude. What can you conclude from that? You know they're complementary. 3 out of 90. So my next step is going to be my conclusion. I know that angle 1 plus angle 2 equal 90, and angle 3 plus angle 4 is equal to 90. I know that because of? That's the definition of complementary. Now see, this is where you could write your proof a little bit differently. I like to write both of those equations in the same step because these were in the same step, but you guys could have written those in their own line. So there's different ways that you can tailor your proof. All right, so now I have my given and then the conclusion I could make based off of that. Now I kind of have to figure out where to go from here. What's something that I could do with this step to keep going?
Angle 1 plus angle 2 equals angle 3 plus angle 4.
Good. And how do I know that?
Substitution.
Substitution. If they're both equal to 90, shouldn't they both be equal to each other? If angle 1 and angle 2 equal 90, and angle 3 and angle 4 equal 90, they both equal the same thing, so they should be equal to each other. The substitution, because I took this 3 plus 4, which was equal to 90, and I plugged it in for the 90 over here. So that's why it's substitution. I just plugged it in because they were equal. Is there anything more I can do? Is there any more manipulation I could do from here? Anything else I can do? No, from here you can't really do anything else. There's no substitutions you can do. There's no really subtraction or anything. We don't know anything more about this yet. So once you guys have exhausted your given, go back to the picture, see if there's anything new you can add. Is there anything else from the picture that I might be able to write down in this proof? Angle 2 and angle 3 are equal. Remember when we made note of that when we looked at the diagram? How do I know that angle 2 and angle 3 are equal? They're vertical angles. Vertical angles are congruent. You don't want to say definition of vertical angles because the definition of vertical does not include the fact that they are congruent. So you just say vertical angles are congruent. With this new information, how can I go back to where I stopped previously and adjust this a little bit more? Now that I know that 2 is equal to 3, what can I do up here? That's eventually going to happen, but don't go too fast. How can I take this and kind of adjust the previous step? Really? 2 is equal to 3? I have an equation that has both a 2 and a 3 in it. Substitute and rewrite the equation. Instead of having a 2 and a 3 separate, if they're the same, I can substitute this 3 out for another 2. Okay, remember what I said, when you have an equation, and then followed up from that, you have some sort of equivalence here, you can swap that out for something in the previous equation. So instead of writing a 2 and a 3 separate, I'm going to write 2 2s. You could have also written 2 3s if you wanted to. Doesn't really matter. So we're about to do what Carmen noticed. Oh, by the way, that's substitution property. No, don't give it away too soon. Oh, goodness. Substitution property, right? And then what can I do from here? Now that I have the exact same thing on both sides, what can I do? I can subtract them away to just have 1 is equal to 4. That's the subtraction property. Now, I know you guys are tempted to just write this from this step, right? But our little person reading this proof doesn't have the algebraic foundation to do that. So you need to physically state that if you know that they're the same, you can write it that way, which allows you to then subtract them. You have to state it that way to follow along with the logic of the proof. So don't make too many big steps, real steps. All right, is there anything I can do from here, really? Okay, when you guys hit another roadblock, let's go look at the picture again. Let's go back and look at the picture. If you see anything else that might be, I now know that angle 1 is equal to angle 4. Let's take a look at our proof now. I'm trying to prove that 5 is equal to 6. So we have to somehow bring those into the picture now. We've used everything that we could based off of our given and the vertical angles. Now I have to bring 5 and 6 into the picture. How can I do that?
1 plus 5 equals 180 degrees.
Okay, 1 plus 5 is equal to 180, but what else? 4 plus 6. Do you guys see that in the picture? 5 and 1 added together would be 180, and so would 4 and 6, bringing in the things that I need for the proof. How would I know that? We're going to use linear pair here. Supplementary, you can't use the idea of supplementary unless they've introduced it to you in the given. So whenever you guys need to pull that out, the 180, reference linear pair instead of supplementary. Okay? So linear pair is a given inside of the picture. If 2 angles together create a line, they're called linear pair. So we're just going to reference linear pair here. Okay, cool. So now we have new information. With this information, let's keep going. What can I do from here? I know that 5 and 1 add up to 180. I also know that 4 and 6 add up to 180. Okay, similar to what we did above when we had the complementary idea. If I know that both of these things are equal to 180, I know that both of those sums should equal each other. It's another what property? It's another substitution. Took the 4 and the 6 and I plugged it in for the 180 in the previous equation. All right. Is there any previous information I can now use? Yes.
Since 1 and 4 are equal, you could do 5 plus angle 1 equals angle 6 plus angle
So instead of writing 4, since I know angle 1 and angle 4 are congruent, instead of writing 4, I can write another 1. What property lets me do that? Substitution again. So I use the previous step, the fact that angle 1 and angle 4 were congruent, which we got previously, to go ahead and manipulate my equation. Now what can I do? I can subtract and get 5 is congruent to 6. That's subtraction property. Is that what my proof statement was? So I'm trying to prove that 5 and 6 were congruent? Yeah, it's over there. We're done. So again, your strategy with creating these proofs is start with the given and do everything that you can with the picture until you're completely stuck, and then bring in the information. You notice that we didn't have 5 and 6 until we brought it in after we were done with everything else. So you have to make sure you bring in the information for your proof statement nearer to the end so you can manipulate that information to get to your last statement. Okay? Questions on this one? That was a little bit of a big one, right? This is probably the longest type of proof you guys will see. The other ones that you will see, particularly on the test, they're not quite this long. This is an example of one of the longer types of proofs you might see. So let's take a look at the one underneath it now. This one's significantly shorter. Okay. I have these 3 angles. I know that angle 1 and angle 2 are supplementary, and then I know angle 3 and angle 2 are supplementary. So that's the first step in my proof. The given. So I'm going to go ahead and write those down. All right. Based on that, what's a conclusion I can make?
Angle 1 plus 3 equals to 1, and angle 2 plus 8 equals to 1.
Yeah. I know that because they're supplementary, they must add to 180. And how do I know that? It's the definition. That's what we learned about supplementary. Right. We can take our 2 pairs of angles and we can set them equal to 180 to write our equation. Okay. Now what? I have 2 equations. Can I manipulate them in any way to get to the next step? Let's do.
Angle 1 plus angle 2 equals angle 3 plus angle 2.
Okay. Since they're both equal to 180, they're equal to the same thing, they should be equal to each other. And what property lets me write the equation this way? It's a substitution property. Anybody spot what we're going to do next? Okay, do we have the same thing on both sides? Okay, so I can subtract the 2 away by the subtraction property. Let's look back at the proof. What was I trying to prove? The angle 1 and 3 were congruent. Did I do that? Yes, I did. So I don't have to keep going. I'm done. All right. Questions on either of those 2 proofs? How would you change it? Well, I mean, if you wanted to add an extra step in there, it's completely unnecessary, but you could also rewrite it as 1 plus 2 equals 2 plus 3. That's using the commutative property and then subtract them. But if you can algebraically prove that it's accurate from here to just take the 2's away, then you can do that without having to do the extra step. All right, let's take a look at this one. No more supplementary. Different ideas. This one says that angle 1 and angle 2 form a linear pair, and then they have segment AB has some sort of relationship to segment BC. Do you guys know what that symbol is? The upside down T? It means perpendicular. That symbol, maybe draw a little arrow and tell yourself that. The little upside down T is a symbol for perpendicular. We'll learn that more in detail in Unit 3. So AB is perpendicular to BC. So that's why I drew the little 90-degree angle in there. So that's our definition of perpendicular. Hopefully you guys know that. You guys know perpendicular, right? I hope. Perpendicular means that they create right angles. Alright, I'm trying to prove that angle 1 and angle 2 are congruent. So we have to figure that out based on only the fact that they are a linear pair and that AB is perpendicular to BC. So what would my first statement be? When you guys have two givens that are completely unrelated, the fact that we have a linear pair and the fact that they're perpendicular are unrelated, we are not going to write them in the same line. We're going to pick one given, write that down, and do as much as we can with that, and then we're going to write the next given and proceed from there. Don't try to write two different givens in the same line, because you're going to forget when to bring it back and use it. So separate them and bring them in when they're relevant. So I'm going to start with the first given, the fact that they're a linear pair. What can I conclude from that? Okay, so they equal 180 when you add them together. Definition of linear pair. Based only on that equation, is there really anything else I can do from here? I can't do substitution. I don't have any new information yet. So I'm going to leave that alone. I've exhausted the first given. The next thing you want to do is now bring in the following given. Once you've used the first given all the way, can't really do anything else with it. Now you're going to bring in the next given, the fact that AB is perpendicular to BC. So our second given. All right, let's get as much as we can out of that. If they're perpendicular, what conclusion can I make? AB equals BC? Angle 1 equals 90? We'll get there eventually, but we have to actually take a really short middle step. Do you guys know what the actual definition of perpendicular is? Make what?
Right angle.
Right angle. So we have to reference right angle first. Can't go straight to 90. If we're going to reference the definition of perpendicular, which is what we would have to do since we know it's perpendicular, the next thing we're going to reference is the definition of perpendicular to get something out of it. The definition of perpendicular does not say it creates 90-degree angles. It says it creates right angles. So if we're referencing the perpendicular definition, we have to use the exact wording. So I know that angle 1 is a right angle. Now what can I conclude, since I know what a right angle is? It's 90 degrees. So now I can say angle 1 is 90, because that's the definition of a right angle. You have to break it up. Can't make too many assumptions or jumps. Alright, so that's both of my givens. Yeah, go ahead.
So if we were to skip that one step, are we still got to the right?
It would not be all the way correct. I'm going to be lenient when I grade proofs, but it would not be all the way correct. So I've exhausted both my givens. Now, is there anything I could use with both of them kind of together? Tatum?
90 plus angle 2.
Okay, so instead of writing this equation up here the way it was written before, I now know that angle 1 is equal to 90, so I can substitute. I can rewrite this equation I had previously and use new information. Create a new format. 90 plus angle 2 is equal to 180. That's substitution again. Alright, I have a brand new equation now. What more can I manipulate? Okay, so I could start solving this, right? What could I do? And subtract 90 from both sides. That's your subtraction property. So when I subtract the 90 from both sides, the 180 turns to just 90. So let's take a look back at the proof. What was I trying to prove? I'm trying to prove that angle 1 and angle 2 are congruent. Can I jump there from what I have now?
Yes.
How? They're both 90, right? So instead of this equation that I wrote previously, can't I take this 2 and put it in the place of this 90? Yeah. Sure. substitution problem. I was able to reach what I was trying to say. Questions on that one? I am going to let you guys do this one on your own. Notice I have marked up the picture. You always start that way first. Add the givens and then any extra information you can find or gather from the picture. Put that in the diagram. Start with your given and go. I'll give you guys a few minutes.
that's fine, but then there should be a fourth one based on the definition.
Alright, let's go ahead and take a look together. There are several different ways you guys can approach this one. So what I'm going to show you on the board is really just one way. I saw a couple of different ones as I was walking around. As long as each of your steps can be supported algebraically and they're valid, then you're good to go. But if you're not, if your answer that you wrote is different than what's on the board and you want to verify with me that it's correct, then call me over and I will make sure that I go over it with you guys. So the first thing you guys should do is obviously start with the given. So that should be the same for everybody. The route you take from here may be a little bit different, but that should always be how it starts. Now there are a couple different ways you guys could go from here. You could introduce the idea that you guys have linear pairs. You can introduce the vertical angle. It really just depends on what direction you want to go in. I went ahead and I started with the vertical angle idea. And again, you could have started with the supplementary first, right? You'll bring in vertical angle eventually. I just chose to bring it in first and then the supplementary idea later. It's your choice what route you want to take. So I know that angle 2 is equal to angle 4 because it was given. I know angle 2 and angle 1 are congruent because they're vertical angles. So I went ahead and I made this conclusion. Angle 1 is congruent to angle 4 by using substitution. So I've used the given, I've used the vertical angle, I can't use that really anymore. So from here I'm going to look back at the picture and I'm going to look at the prove. What do you notice about the prove? 1 is supplementary to 5. Do I have 5 anywhere in here yet? No. So I need to now bring in 5, the rest of the prove statement, so I can actually get to that equation. So somehow I have to incorporate the 1 and the 4 and the 5. Bring 5 in now. So how can I incorporate the 5 as the next step? Yeah. Looking at the picture, I know that angle 4 plus angle 5 is equal to 180 because they are a linear pair. So I know that they're going to be supplementary. Now that I have this information, I brought in 5. How can I use previous information to move forward? Yes. And how do I know that? Yeah. To do substitution, since I knew the angle 1 and 4 were the same, I manipulated this equation to turn it into a 1 instead of a 4, because it's closer to what I wanted to the proof. Sorry, closer to what I wanted for the proof statement. So now I know angle 1 plus angle 5 is equal to 180. What can I conclude from there? They're supplementary, because that's the definition of supplementary. So that was my proof. You could have taken a couple different routes to get there. As long as you introduce the idea, you could also do like 3 and 1 are supplementary, 3 and 2 are supplementary, subtraction, all sorts of different ways to manipulate equations to get here eventually. As long as it's all valid, using linear pairs and substitution and subtraction in valid formats, then you're good. So proofs can take as long or short as you can get it to be as long as it's valid. Questions on that one? No? Great, so you guys do have homework to help you practice, but I have another thing. I have a piece of paper with 4 extra proofs on it, because proofs is really just takes practice until you get used to doing them. So I have 4 proofs. One of them I think is a little bit tricky, but the others aren't too bad. You're just going to have to draw the lines and everything yourself. So I'm going to give everybody a copy so you guys have this. You can do more practice. If you would like to, since we have a little bit of time in class, I can have small groups move to the back and you can use the whiteboards to do the proofs together if you'd like to work in small groups. Or you can stay in here, do homework, whatever. But I'm going to make sure everybody gets a copy of this. Okay? If I run out, I'll go ahead and make some more. But does anybody have any questions before we move on from the lessons? Alright, I have quiz 2 graded, and I'm going to show you guys now. I'm almost done, but I'm not quite done with quiz 3. So maybe show you guys that at the end of class if I finish grading while you guys are working, or I'll show it to you guys. One thing before I forget to tell you guys, hold on, let me finish the video.